Hi, in this video we're going to look at how we can coerce a float to an integer. So in other words, we want to take a float number, a floating point number, potentially with digits after the decimal point, but we want to only take an integer of it, an integer approximation essentially. So that means that we're going to have in general data loss. It's inevitable. If we have 10.2, well, what is the integer that represents 10.2? Well, it's not going to be 10.2. It's going to be 10. It's going to be 11. Maybe something else, but it's certainly not going to be 10.2 because that's not an integer. So we have data loss. So there's different ways that we can go ahead in terms of how do we want this data loss to happen. And what I mean by this is, let's take a look at some numbers. Let's look at 10.4. If we want to coerce that to an integer, well, what should it be? Should it be 10? Should it be 11? Well, there's cases where, you can make the argument that, yeah, I want it to be 11. Maybe that's what you want, because maybe it's, the number of times that you have to run a loop in order to make sure something gets completed. And maybe you do a calculation and it says that's 10.4. Well, that means that 10 isn't quite enough. 11 will be enough. So in other words, you might actually want to take 10.4 and make it into 11 when you look at it from an integer perspective. In other cases, maybe you're doing computations or something, and you'd say, well, no, I want to take the lower number. I want to take 10. If we look at 10.5, there again, where do we go? Is that 10 or is that 11? If we round using rounding up, the kind of typical rounding we're used to, we'd say, well, we're going to take 11. Although 10 could be an equally acceptable value. What about 10.6? Well, that one maybe, yeah, we'll make that 11. That's closer to 11. We'll take the closest integer. And then also you have 10.001 or 10.9999. Where do you want to go? Do you want to go to 10? Do you want to go to 11? Maybe something else, but it has to be an integer. So there's different methods we can use to do all this stuff, and we'll take a look at that in the next few videos. So we have truncation, we have floor, we have ceiling, and we have rounding. So in this video, we'll take a look at the first three. We'll keep rounding for a separate video because that can get into a pretty kind of detailed subject. But in all cases, you have data loss. So just pick your poison. You're going to have some data loss when you convert to an integer. So let's look at truncation first. So truncation simply returns the integer portion of the number. So basically, it ignores everything after the decimal point, and you just get the number that's to the left of the decimal point. You can think of it that way. So the math module provides us with a truncation function called trunc. So we can use it this way. We have to import math first, obviously, and then we can call math.trunc 10.4, and that will return 10. 10.5 will return 10. 10.6 will also return 10. Right? We're just ditching what's after the decimal point. And it works the same way with negative numbers, right? We just ditch what's after the decimal point and we just retain the integer portion of that float. Now, I want to talk about the int constructor very quickly here, because the int constructor in Python accepts a float. So it uses truncation when casting the float to an int. In other words, if you say int of 10.4, it's the same as saying trunc of 10.4. Right? And the same thing with these other numbers that we saw before. So if you don't want to, if you want to use truncation and you don't want to import the math library, or you don't want to import just the, trunc from the math library, you can also just use the constructor for int. It will essentially return the same thing. So next we have floor. So the floor of a number is the largest integer that is less than or equal to the number. So in mathematical notation, the floor of x is the max of all the integers that are less than or equal to x. So let's take a look at an example of that. It makes more sense if we use a number line. So here we have the number line 10, 11, and then we have 12, 13, 14, and then 9, 8, 7, 6, etc. on both sides. And 10.4 sits between 10 and 11. So the floor is the largest integer that is less than or equal to the number. So we're looking for the largest integer that is less than x or equal to x. But in this case, less than x. It's 10. So 10 is the floor. Now we also have to consider negative numbers. What's the floor of negative 10.4? Well, you might be tempted to say it's negative 10, but it's not. Why? Let's look at it on the number line again. So here's minus 11, minus 10, and here's minus 10.4, right, sitting right between those two. Again, what's the floor? It is the largest integer less than or equal to x. Well, in this case, the largest integer that's less than x is negative 11. And so that is the floor. So the floor of 10.4 is 10, but the floor of negative 10.4 is negative 11. So for positive numbers, floor and truncation are actually equivalent, right? If we took the trunk of x, we would get 10, and the floor of x would also be 10. And for any positive value, that will be true. But that is not the case for negative values, right? The truncation of x in this case would be negative 10, but the floor is negative 11. So be careful. Floor and trunk are not the same thing when it comes to negative numbers. Now I also want to talk very quickly again about floor division. We saw this div operator a while back. And remember how we defined it. We defined the floor division in combination with the mod operator. Right? And we said it satisfied this equality here. So this was integer division, and this was the mod operator. Now in fact, floor division, and the reason why it's called floor division, it's because it's defined this way. A div b is precisely equal to the floor of a divided by b. So that's why we call that a floored division. And if we use this definition for floor division, then it will drive the definition of the mod operator, and it will always satisfy that equality. Okay. So let's look at the floor again. So the math module provides the floor function. So we can get it from the math library. And if we get, say, math.floor of 10.4, we get 10. If we look at 10.5, obviously any number within this interval here, but not including 11, will floor to 10. Right? If we have a number equal to 11, its floor will be 11, right? Because the largest number less than or equal to x. Right? So in this case, anything from 10 up to but not including 11 will floor to 10. And similarly with negative numbers, if we take any number in this interval here but excluding negative 10, they will floor to negative 11. Okay, so all these will floor to negative 11. So the next one is ceiling. Ceiling is kind of the opposite of floor. Floor, we took the largest integer less than or equal to the number. For the ceiling, we're going to take the smallest integer greater than or equal to the number. So again, in mathematical notation, the ceiling of x is the minimum over every integer such that that integer is greater than or equal to x. Again, let's look at a number line. So here's our number line, 10, 11, and obviously it continues on both ends of the spectrum, and x sits somewhere inside that interval. So what's the ceiling? Well, the ceiling is the smallest integer that's greater than or equal to the number. Well, that would be 11 in this case, right? 11 is greater than x. 10 is not greater than x. 12 is also greater than x, but it's not the smallest integer greater than x. The smallest one is 11, so that's our ceiling. And obviously any number that falls within this interval, excluding 10, will ceiling to 11. Now let's look at negative numbers. So negative numbers, again, let's look at a number line. Negative 11, negative 10, x sits right in between. The ceiling, therefore, is going to be negative 10. So the ceiling is negative 10 for any number in that interval here, excluding negative 11. Obviously, if the number is negative 11 or the number is 10, then the ceiling in this case would be 10, right? Because we're looking at every number greater than or equal to the number we're looking at. So if we're looking at 10, then I, equal to 10 is equal to 10, and therefore the minimum will be 10. So anyways, just be careful with your open-close intervals on the floor and the ceiling. So we'll look at some code next in the next video. Thanks for watching, and I'll see you in a bit.